So we've taken a look at the formulas involving adding and subtracting cosine functions. Now we're going to take a look at adding and subtracting sine functions. So again, one reason we bother to learn these formulas is if we have something like this. We're looking for the sine of 5 pi over 12. Well, 5 pi over 12 isn't an angle that we know. We know 6 pi over 12 and we know 4 pi over 12. 3 pi over 12 that reduce to other kinds of angles, but this 5 pi over 12, we don't know how to find the sine function of that. So what we're going to do is look to see how we might break this function up, excuse me, not the function, the angle up, so it's something we are able to evaluate. So we can consider the sine of 5 pi over 12 as being equal to the sine of 3 pi over 12 plus 2 pi over 12. So we can think of the sine as 5 pi over 12 would be 3 pi over 12 plus 2 pi over 12. 3 plus 2 gives us our 5 in the numerator. Well, in case you're saying, well, what good does that do? If we reduce these fractions, we can see that 3 pi over 12 reduces to pi over 4, and 2 pi over 12 reduces to pi over 6. And pi over 4 and pi over 6 are two angles that we recognize that we know the trig functions for. So I'm going to call this pi over 4 our alpha and pi over 6 beta. And same as the other examples, I could call this beta and this alpha because this is addition. It's not going to make a difference. So if you look back at the top of your page there for the formula, since we're looking at the sine of two angles being added, the formula we have says that if we're looking at the sine of an alpha plus a beta, two angles being added, that's equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So there's our formula. And now let's identify, we said alpha was pi over 4, so we're looking at the sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 times the sine of pi over 6. So I can hear some of you groaning that they're all these numbers, but it's two angles, alpha and beta. We're just substituting them into this formula. So hopefully you can recognize here that we're going to need the sine and cosine of both of these angles. So let me switch colors just because I get bored. So starting with our pi over 4 here, we need the sine of pi over 4, which we know is square root 2 over 2. And then we're going to need the cosine of pi over 4, which is the same, square root 2 over 2. So we have our sine and cosine of our first angle. Now we're going to need the sine and the cosine of our second angle, which is pi over 6. So sine of pi over 6, that is 1/2. And the cosine of pi over 6 is square root 3 over 2. So we have the 4 pieces of information that we need to go back to our formula and substitute. So here, sine of pi over 4. So we have square root 2 over 2 times the cosine of pi over 6, which would be square root 3 over 2 plus, now cosine of pi over 4 is square root 2 over 2, and the sine of pi over 6 is 1/2. So there's our multiplication to do. Let me move this up here. And so square root 2 times square root 3, this would be the square root 6. 2 times 2 is 4. And now over here, square root 2 times 1. This is the square root 2 over 4. And finally, we can add these since the denominators are the same, 4. and we have the square root of 6 plus the square root of 2. And as in the other example, we are done here. You cannot say this is the square root of 8, because these are under radicals. We can't add them unless they are the same. So now this next example of sine. Notice I've switched it up into radian measure here, just so we don't forget. We can look at angles using degrees or in our radian measure. So whoops, I went too far. This is the example we're going to look at now. So just now we took an angle, one angle, and we broke it up into two angles to use our formula to help us get the sine function that we were looking for. In this example, what we have here looks suspiciously like one of the formulas on the top of the page. We have a multiplication of sine and cosine, a subtraction symbol, and then another multiplication of cosine and sine. And if you go back to the top of the page here, you can see that it's this formula here that we are looking at, the sine of the difference of two angles. So this here would be representing the sine of an alpha minus a beta. So let's identify our alpha and beta. Here, I'm going to say this is our alpha here, 7 pi over 12. This represents our angle alpha, and our second angle here, pi over 12, this would represent our angle beta. So here we have the sine of alpha minus beta. So this would be the sine of 7 pi over 12 minus pi over 12, which would be equal to the sine of 6 pi over 12. 7 minus 1 is our 6 pi over 12. And we can reduce this. So this is the sine, 6 pi over 12, reduces to pi over 2, 90 degrees. And we know that the sine of 90 degrees is 1. So from both of these examples now using sine and cosine, I think you probably agree with me that using the formula when it's given to us and recognizing which one it represents and substituting the angles in is a little bit easier than using the formula to do the expansion.